Okay, continuing on. So if I wanted to sketch the graph of root x, like get an accurate sketch without necessarily using to, is we want to first sketch the base graph of just y equals x. So we have a pretty good sense of what that is going to look like. So I'm going to equals x, kind of lightly. Now I want to draw the graph of the square root function. So I want to go back to the summary of information that we just talked about to help me graph our new function. Anything that's less than 0, so all of this part of the graph is going to no longer exist. So that's pretty much gone. So now I'm just worrying about anything that's above the x-axis. Okay. I'm going to identify invariant points. So an invariant point is going to be my x-intercepts. So it's going to stay the same. And when our y value is equal to 1, which is this point. Okay. And this is just kind of like a little bit more of a, still want it to be fairly accurate, but more of a sketch. So in between, when y values are between 0 and 1, my function above this line, so I'm going to draw it above, and then anything beyond 1, my function should be below this line. So my function is going to look something like that. And that's it. Okay, this one's fairly basic because we're going to get a little tougher as we move on. All right, what if I wanted to take the square root of 3x minus 1? Oh, let's go back and talk about domain and range. So the domain of this function is straightforward. It's going to be anything greater than 0, where x belongs to the reals, and my range is going to be the same. Okay. All right, second graph. We are going to graph the line 3x plus 1 graph, or 3x minus 1. So to graph this, rather than using a table of values, I'm going to use my skills from Math 10 on how to graph a linear line. I'm going to look at the -1, which is, and then I'm going to use my slope of 3 over 1. So I'm going to go up 3 and over 1 to get a second point, and to the left 1. So now I'm going to take my ruler. I'm going to get an accurate sketch of this. I'm going to draw it lightly because technically this is not the line I'm trying to draw. Okay. Again, now we want to take the square root of this function. Well, to take the square root of the function, we're going to follow the same summary. Anything below the x-axis, no longer. The y-intercept, or sorry, the x-intercept, and the value at y equals 1 are going to be invariant. Okay, anything between 0 and 1, my graph is going to be above, and everything else is going to be below. So it's just a sketch. Okay, so those are the key things that I'm looking for. I'm looking for you to clearly identify these, and that the curve between 0 and 1 is above the original function, and everything else is going to be below. Okay. So now we still want to draw our base function of y equals x. We are then going to take the square root of that, and then at the end we're going to apply this transformation of a reflection. Okay? Oh, actually, before we move on, I forgot, take the domain and range. So let's talk about the domain and range of this. Should be, technically, x has to be greater than or equal to 1/3. This equation for 0, when at y is 0, we'd get 1/3. And our range is going to be greater than 0. Okay. All right. So we are going to sketch the graph y equals x. So we should all have a good sense of what that looks like. If I can get it here. There we go. Okay. All right, so now I'm going to take the square root of this function. So again, this is going to disappear because I can't take the square root of a negative y value. And now I'm going to draw this in a dotted line. Variant points would be at 0 and 1. I'm going to draw my dotted line. Make it look a little prettier. Okay, so there it is. Now, so this is y equals root x. Now I'm going to finally apply this negative. And so using this negative tells me that there is a reflection in the x-axis. So these points, this at 1 is now going to be negative 1. So now my graph should look like this. Okay? Domain and range. Domain should be x is greater than or equal to 0. And our range, because I reflected it, should be anything less than or equal to 0. Okay. All right, moving on. Okay. So what we want to do is we want to start off with this original function. So your base function is always the function that is inside the radical. Okay, so anything that's inside the base function that we're going to start off with. So I want to start off by graphing y equals x squared plus 4. And it needs to be fairly accurate. Okay, so x squared plus 4 means my vertex at 0, 4. For 1 that goes over, it's going to go 1 up. For 2 that goes over, it's going to go 4 up. So this gives me a good sense of what my original function looks like. Okay. All right, so there's my original. Now I want to take the square root of this function. Well, technically, my entire function is above the x-axis, so I need to square root this entire function. How do I get a gauge of what this graph is going to look like? What I'm going to do is I'm going to literally take the square root of all of my identifiable points that I've kind of created here, and I'm going to take the square root of those values. So let's start with the vertex. Remember, we're always square rooting the y values. So the square root of 4 is 2. So that is my new point. This 5 is approximately 2 point something. So that's going to be somewhere in here. The square root of 8 is point even more, right? So we can start to see that this graph is also going to create a parabola, but it's going to be a little bit of a wider parabola. So that is what our function is going to look like. What's the domain? Well, all real numbers. That has not changed. The range is going to be anything greater than or equal to 2. Okay. Okay, again, so moving on. We've already graphed something similar to this. We now want to, there's an extra portion to it by adding 3. So we're going to start by graphing our base function, which is y equals 3x minus 1. So y-intercept of negative 1, up 3 over 1, the sense of this line. So there it is, lightly drawn. I'm going to identify my invariant points, which would be here and here. My graph, I'm going to draw this as a dotted line. Okay, so there it is. So now that I've taken the square root of this line, 3x minus 1, I'm now going to add this transformation, and I want to move this 3 units up. So I'm going to move this up, 1, 2, 3, 1, 2. So we can kind of see We want to keep the same shape happening, a higher graph. So our domain of this function should be x has to be greater than or equal to 1/3. And the range should be anything greater than 3, because we moved it up 3 units. Okay, so this one's a little tougher. X squared minus, so what does this original function look like? Okay, so we need to graph y equals x squared minus 9. So I apologize, this is going to go down 5, 6, 7, 8, 9. So we'll say it's about here. So this is my vertex, right? And approximately, right, 2 over is going to be 4 units. If I went 3 over, then it's going to be 9 units up. So technically my x intercepts of this function are going to occur at 3 and -3. So again, how did I figure that out? This is an x squared value. So what that means is for every 1 unit horizontal, square that unit to get my vertical distance from my vertex. So 1 unit over, if I square that, would be just 1 unit up each side. Horizontally 2 units over, I'm going to square that, should be 4 units up. So 1, 2, 3, 4, so that's how I got those points. 3 units over should be 9 units up, which is brings us to this x-intercepts. Okay, so I'm going to lightly sketch my curve here. It's just a sketch. All right, so now I want to take the square root of this. So how do I take the square root of this? Anything that is below the x-axis no longer exists on my graph. So technically I'm just taking the square root of this branch and this branch. I'm going to identify my invariant points would be at my x-intercepts and when y equals 1. Okay, and then my curve is going to, anything that is between 0 and 1, my curve is going to go above that line. And then anything beyond 1, my graph is going to go below that line. So I'm going to get a branch that looks something like this, and the same thing on the other side. Oh, and I'm going to draw this as a dotted because I still have to transform it at the end. Transform it at the end. Okay, finally, we need to move this graph 1 unit up. So this final graph is going to look something like this. It's just a sketch, so the thing that I'm looking for is it transformed properly? Is our branches opening? Are your branches kind of in the right position? Okay, domain of this function should be anything less than or equal to -3 or greater than or equal to a +3. My range should be anything equal to 1. Okay, so this gives you an idea to sketch the square root of a function. Start with your base function, take the square root of it, and then apply any basically vertical translations or vertical transformations to it. Okay. All right, and then example 3. Given the point y equals f of x, does it exist on the square root of y? Okay. So if this is my point on my original function, would I have a point that existed on my new function? And the answer would be yes. Because remember, root of the function, I am square rooting the y values. So technically this point would become 3 is not going to change, but the 4 would become a 2. What about here? E value is negative. The y value is still positive, so this is still okay. So yes, this would actually become, 2 would stay the same, and then I'd take the square root of 5. Third point, no. Because I cannot take the square root of a negative value. So biggest thing to remember is you cannot take the square root of, you're square rooting the y value, square root of a negative. All right, and that is square rooting a function.